Questions involving motion under gravity mean that we take the acceleration to be either plus or minus gravity, which is usually given as 9.8 meters per second squared. Also means that at its highest point, that will be when the velocity in the vertical direction is 0. So here's a typical example. A rocket is projected from a point 2 meters above the ground at a speed of 15 meters per second and an angle of 60 degrees and travels freely under gravity before hitting the ground 30 meters away. What that's told us is our acceleration is going to be g equals 9.8 meters per second squared. Our initial velocity, we're told, is 15, and the distance it travels horizontally is 30 meters. Find the time it takes from launching the rocket to hitting the ground. So we need to find the time t. We know that the horizontal distance that it's travelled is 30 meters, so s equals 30 for this. And what we know is that acceleration, if we're talking about acceleration being gravity, then that acts just in a downwards direction, and therefore there is no horizontal acceleration, so that is 0. And we need to work out what the horizontal initial velocity is. So we know that u equals 15 meters per second, and we were told that it goes off at an angle of 60 degrees. Therefore, we want this component of the initial speed. That's adjacent, so that part is going to be 15 cos 60 degrees, and 15 cos 60 degrees is a half of 15, so that's 7.5 meters per second that we're going to be using there. So now we need one of our Suvat equations. So the one that fits with the information we've got here is when s equals ut plus a half at squared. So s is 30. We've got 7.5 t. And then the rest of it is just going to disappear, of course, because our a is 0. So that means our time is going to be 30 divided by 7.5, which is going to give us a time of 4 seconds. The next thing we're going to find is how far up does the rocket reach, the highest point that it goes in the vertical direction. So what we're looking for this time is SY, I'm calling it, because we want that vertical height that it's travelled at that point. Remember, we talked about right at the beginning that when the rocket reaches its highest point, then the velocity of it is 0 in the Y direction, and the acceleration that it will be under will be minus g. We also need to know what its initial velocity was. So we're going back to that little picture again. So it was u going off this way, which was 15. It's 60 degree angle in here. This time we want this component. So that's opposite the angle. So that one is going to be 15 sine 60 degrees, so that's 15 times root 3 over 2, so that's our initial velocity. So again, we're going to use one of our Suvat equations, but this time we're going to need v squared equals u squared plus 2as. So our v is 0 in this case. Our u, all of that squared, so that's 225 times 3 all over 4. We'll deal with the rest of that in a minute. And our acceleration is minus g, so that's minus 2g times the s that we're trying to work out. So if we rearrange that, we're going to get that sy equals 225 times 3 over 4, and we'll need to divide by that 2g like so, and this is a definite calculator job, and once we do all of that with the calculator, we'll get 8.61 meters. However, that is not the answer to our question. I'm going to go back to the original diagram to explain why not. So we've just calculated SY, but that is in relation to where it's set off from here. So what we've calculated is this distance here, whilst we want the full distance from here to here. So we're going to need to add the 2 meters on to get that full distance. So if we add on the 2 meters, then the highest point it reaches will be 10.61 meters. Now we're going to find the velocity of the rocket just before it hits the ground. The horizontal component of the velocity will not have changed, so this will be the same as u of x. Remember, there was no acceleration in the horizontal direction, so the speed won't have changed in that direction, and we calculated that earlier as 7.5. Now to find the vertical component, we're going to use the fact that we know and worked out earlier that it takes 4 seconds. The acceleration is minus g, and we also previously worked out that the initial vertical velocity is 15√3 over 2. So using this Suvat equation, we can find out that Vy equals 15 times √3 rather over 2 minus 4g. And with the aid of a calculator, that becomes minus 26.21 meters per second. What that actually is telling us is that this component is acting that way and not this way. So now we need to resolve the two components together to actually get V itself. So what we're looking at is we've got Vx acting this way, and then we've got Vy acting that way, and we're going to work out what V is, which will involve not only working out what the value of V is, but also we need to know that angle because it's a vector. We need to know the direction of it. So let's deal first of all with what V itself is. So that's Pythagoras. So V will equal the square root of Vx squared plus Vy squared. And that is going to give us square root of 7.5 squared plus 26.21 squared, and that, when we put that through the calculator, gives us 27.26 meters per second. And now what we need is the angle of it as well. Tan of theta is going to be Vy over Vx, remember? So that equals our 26.21 all over the 7.5. Using the calculator, that leads us to theta equals 74 to the nearest whole degree, and that would be described as being below the horizon there.